Dear students, today we will study chapter 1, real number. During previous classes you have studied all these numbers: natural number, whole number, even number, odd number, prime number, composite number, integers, rational number, irrational number. All these number comes under the topic real number. All these numbers, you can see that all these numbers are the part of real number. You can plot all these number on real number line. All of you are familiar with the number line. You just know this is the number line, okay, and this is 0, and right to 0, you know, right to 0 there is a positive real number, and left to this 0 they are negative real number. Here all number positive real number, and from left you will see that negative real number. And you can all of you have familiar with this number line. On this number line you can plot every number as explained above. You can plot all the number on this number line. You had also learned the plotting of rational number and irrational number. These two type of numbers you have already learned how to plot these two type of numbers on this number line. But today we will deal with integers, especially positive integers. Now we will deal with positive integers. We will start with the simple operation between the integers, okay, that is called division. We will start with division. All of you know the division between two numbers or integers. Everyone knows. Let us recall once again with one example. Suppose we have to divide 36 by 7. Okay, so now 5 times it will divide like that. So you see that here 36 is our dividend. Everyone know about this, and 5 is our quotient, and 7 is our divisor, and 1 is our remainder. Okay, now you know the relationship between all these terms. Everyone knows this relationship. We have already done in previous classes. Dividend equal to divisor into quotient plus remainder. Okay, all of you have studied these type of relationship, in the previous classes. Now we will suppose we will take two general number a and b. Okay, these are the positive integers, you can see, and a is greater than b here. Now here we will divide a by b. Okay, then suppose you get quotient q and remainder r. According to that relationship, dividend is dividend is a here, then dividend equal to divisor is b here, divisor into quotient plus remainder. Okay, according to this relationship, dividend equal to divisor into quotient plus remainder, we will write dividend equal to divisor into quotient plus remainder. Okay, so now here we will write the limitation of remainder here. What are the possible values of remainder may have? So you see that the remainder may be 0, but remainder should always less than our divisor. Okay, in the previous example you see that remainder is 1 and which is less than our divisor, that is the 7, and remainder is 1 here. So now this remainder can be 0 or any number between 0 to this 0 to 6. Okay, this remainder should be less than this divisor. So according to that, we will put here the limitation of remainder. Okay, now I will repeat this process. I will write this process once again for any two positive integers a and b, where a is greater than b, there exists two integers or numbers q and r, then a equal to bq plus r. Okay, if we divide a by b, then according to that relationship we can write a equal to bq plus r, and what will be the limitation of r is r should be lie between 0 to b but less than b. Line between 0 to and equal to 0 but less than b. Now the whole statement, the whole statement, you can say the whole statement is known as here Euclid's division lemma. Euclid's division lemma. Now we will use this lemma to solve some problems in maths. For example, we will use this lemma to find out SCF, that is the highest common factor between two integers. Since we use this lemma to find out SCF between two numbers or integers, then in that case this lemma is termed as Euclid's division algorithm. Division algorithm. You can say that when lemma is used to solve any problem, then it is termed as algorithm. Let us see one example. Find out SCF between 455 and 42 by using Euclid's division algorithm. Okay, we have to find the SCF of 455 and 42 by using Euclid's division algorithm. So now just I solve it. As you know, SCF is the highest common factor, that is highest number that will divide the both number 455 and 42. So now we will apply Euclid's division lemma to find out this number. Here we see that 455 is greater than 42, so then 455 will be divided by 42. So now you see we will apply for one time this result in 42, and further no division will occur, then we will put 10 here in quotient. In first step we will write English division lemma like that: dividend 455 equal to divisor into quotient plus remainder. Okay, further we will proceed like that. We make this remainder as a divisor and this divisor as a dividend, and further we will start division. In second step you see 7 is the remainder and 1 is the quotient. Again we will apply this lemma: 42 equal to 35 into 1 plus 7. Again we will make this remainder as a divisor and this divider as a dividend. Then you get here remainder 0. Now in third step we will write like 7 into 5 plus 0. Now since we get the remainder 0, then the process will stop here, and in this step what is the divisor here? Divisor is 7, so this divider is termed as the SCF between two numbers. Here we get the result, that is the SCF. So now student, you see that how we have applied this lemma to find out the SCF between two numbers. That means the highest number which will divide both the numbers. Okay, so then in that case this is called the algorithm. Since we apply lemma in 3 steps, so overall this is called the division algorithm, English division algorithm. So now students, we will use this lemma for solving other type of question also. Let us see another example. Suppose there is a question like that: show that any odd positive integer is of the form 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. So now we will see how this question can be solved by using this lemma also. In above question you see that all these terms are in the form of BQ plus R. Suppose according to English division lemma, if A is any number, that can be written like this: A equal to BQ plus R, and here R, the limitation of R is 0 to B. You see that above all the values, all values are of this form, BQ plus R. In place of B, here the 6 exists here in place of B. Then you can say that if we divide any integer A by 6, we get the form like this. So now we will start like this. Suppose we will let A be any positive integer, then by Euclid's division lemma we can write Euclid's division lemma. We will start the question from here like this: A equal to 6Q plus R. You can understand like this: if A is any number and if A divided by 6, you get quotient Q and remainder R, suppose, then you can write a equal to 6q plus r, and then the limitation of r would be 0 to 6. Remainder should be equal to 0 but less than 6. Okay, you can say that how why I choose 6 as a divisor, because in the question it is clearly written in the form of bq plus r. Here we can easily see that we can easily see that the 6 would be the divisor. So we take only 6 here. Now further, we see that remainder can be any number between 0 to 6 and 0 also. So now we will put all the values of remainder and we get different values of a here. What would be the possible values of a? Then we will write the possible values of a may be, if we put r equal to 0, this would be 6q, or if we put r equal to 1, 6q plus 1, or 6, if we put r equal to 2, that would be 6q plus 2, or if we put r equal to 3, we will get 6q plus 3, or if we put r equal to 4, we get 6q plus 4, or if we put r equal to 5, we will get 6q plus 5. Further, we will not put any value because we have to put the values of r that should be less than 6. Okay. Now we will check among these values which one is odd and which one is even. Now you know that the values which can be divided by 2 is odd number, and the values which cannot be divided by 2, the values which can be divided by 2 is the even number, and the values which cannot be divided by 2. Now we will divide, suppose 6q by 2, we will get, this can be easily divided. So now this values is our even value. Now if we divide second one by 2, this will not result in any number. If we divide third number by 2, then you see that this is divided easily. So this is also even number. This number is also even number. Now if we divide this number by 2, this will not result in any value. So this is the, and if you see divide this by 2, then you get here some value, and if we divide this number, we will not get any number. So now you see that among these values, this one, and this one, these three values are the odd values, and remaining values are the even values. So after this step, we will write here clearly the odd positive integer is of the form 6q plus 1, or 6q plus 3, or 6q plus 5. So now students, we will stop here for today. You can do question from exercise 1.1 and post your queries in Google Classroom. Post your queries in Google Classroom. Join Google Classroom by using code. My code is This is the code of my Google Classroom. You can join using this code. You can download the Google Classroom app and join this Google Classroom and post your queries there, and I will make video for your queries and I will post again to resolve your problem.